Hello, everyone. My name is Dominic, and I'm a field applications engineer for Cross Control. And today, we'll be covering the auto-generated code from a ToughGFX project in STM32Cube IDE. This is the code that's automatically generated by the ToughGFX program when developing on maxAI products. Today's video goals will be to cover the core Maximatech configuration files, some user modify files, and our GUI source and include. We'll start by using the demo project for the maxAI 430, which can be downloaded from the website under the products section. We're going to open this project in the STM32Cube IDE and bring it up in our project explorer here on the left side of the screen. You can press on this drop-down arrow to expand all of our main folders throughout the project. We'll start with our user modify files. These files can be found under our project directory, core, and Maximatech. You'll see here we have include, source, and our user modify files folder. Our include and source files manage custom aspects and hardware control of the display. User modify files do this too, but make it much more approachable to edit this data. You can see here in our list of files, we have some important ones. Our J1939 CAN layers and our PGN setup for CAN as well. You can change and add CAN PGNs using these files and set them up to any custom interface or CAN messages you'd like to use in your application. Here, you can also see there's general configuration for the 430. Next, we'll get into our include and source for the GUI portion of our application. This can be found under the ToughGFX folder on the left side of our project directory. You can see here we have our GUI and then include and source. So I'm just going to open both of those up. Today, we're going to focus on main screen, which is the primary screen of the demo application. And we'll open all of our files. Starting with our main screen view.cpp. You can see here we have a view and presenter file for all of our screens, as well as our HPP and CPP versions of said files. Starting with our main.cpp file for main screen, you can see here we are managing a lot of our screen setup and initialization. So we're setting fuse voltages and creating baselines for our values in the future. Main screen view also handles things like key presses. So you can see we have our key update function being called here, and it's managing whether we have a short or a long press and performing navigation functions. A little further down, we have our system's real-time clock. This counts ticks, which the system uses as essentially a heartbeat to manage all of its functions on a regular interval. And finally, built into the device, we have some hardware abstraction layer code. We are using the device's light sensor to manage the LCD brightness, and you can see how those two values interact here on screen. We're going to briefly jump into a different screen file so that way I can show off some of our other ToughGFX functions that are available. Here, we're going to go back into our project directory and look at the source for our widgets screen and open up our view.cpp file. We'll start at the top. If you notice, our includes use a lot of our Maximatech user configuration files, including things like our user defines, and you can even potentially add a CAN PGNs. So that way you can access your CAN messages from anywhere in the system. But moving forward, looking for our ToughGFX function calls here, you can see we're using those key update calls, like a short press, to modify things on our screen, like changing the color of labels and further navigation features. If we scroll down, you can see that this switch statement is handling all different label types and colors, depending on the key press. and this is set up for each of the keys. We can also see an example of our set and getDL functions. These are also hardware abstraction layer functions in that they change hardware features instead of software GUI features. So in this example, we can see that in our warning light configuration file, depending on if this variable is set, we can change the status of our hardware warning light on the front of the display. Last but not least, we'll look at our presenters.cpp and our HPP files for view and presenter. We're going to go back to the main screen for these. So jumping right in to our source presenter for our main screen, you can see here we're using a lot of very standard C++ calls and object-oriented programming function styles to manage our code. We have some activate and deactivate functions, including our key update and our trigger for our timer. The watchdog and our tick heartbeat are also initialized in this presenter file. These are typically quite bare bones, as a lot of these features like activate and deactivate are not implicitly called in our program, but they are used typically by RTOS, the operating system that runs the device, or occasionally by that heartbeat tick event. Moving on to our HPP files for view and presenter on our main screen, we can see in our view.hpp, we're initializing a lot of our primary functions we saw back in our CPP file. And all of this is encapsulated in a C++ class called source_main_view. Now, all of this code is automatically generated by ToughGFX, so you don't need to worry about getting your syntax correct, but it's important to have a firm grasp on C++ related object-oriented programming concepts to be able to digest this code. Moving to our presenter.hpp, we can again see some basic object-oriented initialization happening here, just setting up some of our functions that we're using later in our presenter.cpp. Thank you for watching this video, and we hope to see you next time.